What do breakthroughs in medicine, clean energy, and space exploration all have in common? They are all rely on one essential method, the scientific method. It's not just used for scientists, it's used to solve any problems. In chemistry, for example, this method helps us understand how substances interact, develop new materials, and even save lives by creating medicines. Let's explore how this systematic process guides discovery.
Let's take a common chemistry problem. How does the temperature affect the rate of a chemical reaction? So step one would be observation and question. You notice that heating certain solutions makes the reaction faster. You ask, why does this happen? Step two is a hypothesis. You predict that increasing the temperature will speed up the reaction by increasing molecular movement. Next, we design an experiment to test the hypothesis. We heat one solution to 100 degrees and we keep the other at room temperature. In order to ensure accuracy, we use a digital scale to measure precise amounts of each chemical and a stopwatch to check the time of the reaction.
During data collection and analysis, we measure how long the reaction takes in each case and look for patterns. If the reaction happens faster at high temperatures, it supports the hypothesis. If not, we refine the hypothesis and test again. This process ensures that our findings are reliable, repeatable, and grounded in evidence so we can make good, accurate conclusions.
The scientific method gives us a clear framework for understanding complex chemical reactions. It also helps ensure accuracy at every step. Here is our graph of the temperature reaction versus the speed of the reaction.
The scientific method isn't just for lab experiments, it drives every major breakthrough in chemistry. For example, the development of polymers, scientists hypothesized how certain monomers might bond together under specific conditions. Through repeated experiments and careful data analysis, they created materials like nylon and polyethylene that revolutionized industries. In medicine, chemists use a scientific method to develop life-saving drugs. For example, they start by hypothesizing how new compounds might target a certain disease. Then they test it on controlled experiments, analyze the results, and refine the formula to ensure that it is safe and it is effective. Without this method, modern medicine as we know it wouldn't exist, and many people would suffer because of this. The method is also crucial for tackling global challenges. Chemists use it to design more efficient materials for solar panels, testing and remodeling them to improve their energy intake and storage. These renewable energy sources help benefit the world and create sustainable practices. The scientific method ensures that every step, from hypothesis to conclusion to data analysis, is thorough, precise, and organized. This process dates back centuries. Aristotle emphasized observation, but it was Francis Bacon who really, in the 16th century, refined this method in the systematic process that we know today. From then until now, it's been the foundation of every major scientific discovery and every civilization, whether it refers to science or not.
So why does the scientific method matter to you? Because it's more than just a process, it's a tool for understanding the world. Whether you're testing a new experiment in chemistry, designing an invention, or solving everyday problems, this method gives you the tools to find reliable answers. Next time you're curious how something works, think like a scientist. Ask questions, form a hypothesis, test it, and analyze the results. Curiosity combined with the scientific method can change the world.